In the vast silence of deep time, long before the earth echoed with the roars of tyrannosaurs or the thunder of sauropod herds, there existed a world both alien and familiar. This was the Late Triassic period, more than 230 million years ago, a time when the Earth was stitched together into a single colossal landmass called Pangia. It stretched from pole to pole, wrapped around the globe like a cracked shell. The interior of this ancient supercontinent was dry, hot, and hostile. A place of brutal extremes where only the most resilient creatures survived. The air shimmered with heat during the day and froze under a blanket of stars by night. Vast deserts sprawled across the interior, while thick monsoons battered the coastlines. Life clung to the edges of survival, adapting in ways that would set the stage for an evolutionary revolution. Before the first true dinosaurs walked the land, the dominant forms of life were strange and primitive. Reptiles ruled the continents, but not the kind we think of today. Archosaurs, the ancestors of both crocodiles and dinosaurs, had already begun to diversify. Some crawled on 4 legs, armored like tanks with thick plates of bone beneath their skin. Others strode on 2 legs, lean and quick, with jaws lined with needle-like teeth. Yet, none had yet risen to the dominance that would define the coming age. Instead, the world belonged to a patchwork of bizarre creatures that bridged the gap between the ancient and the modern. In the sweltering lowlands of Pangia, giant amphibians lurked in slow-moving rivers. Creatures like Metoposaurus, with their flattened broad heads and sprawling limbs, resembled monstrous toads the size of crocodiles. They were ambush predators, lying motionless beneath the surface, waiting for fish or smaller animals to wander too close. They breathed air but lived most of their lives in water, clinging to the last remnants of an earlier era when amphibians were the apex of terrestrial ecosystems. Roaming the dry open plains were creatures known as cynodonts. These squat, tusked herbivores were survivors of the great Permian extinction that had occurred just a few million years earlier. They looked like a cross between a reptile and a mammal, with beaked mouths and barrel-shaped bodies. Their gait was awkward, their skin tough and leathery, and yet they thrived across much of Pangia, grazing on low-growing plants and leaving deep tracks in the dusty earth. Above them towered the rauisuchians, the apex predators of this time. These were massive, crocodile-like reptiles that stood tall on 4 legs and hunted with brutal efficiency. With their deep skulls, serrated teeth, and powerful limbs, they dominated the food chain in many environments. Some, like Pangia, grew to lengths of 6 meters or more, stalking prey across the open landscape with a slow, deliberate menace. Their footsteps thundered across the plains, a sound that few dared to challenge. But even among these ancient titans, change was beginning to stir. In the margins of ecosystems, in the cracks of evolutionary possibility, new forms were emerging. Creatures like Eoraptor and Herrerasaurus, small, bipedal and nimble, began to appear. They were not yet the rulers of the land, but they were fast, intelligent, and uniquely adapted. With hollow bones and sharp, recurved teeth, they represented the first glimmers of what would become the dinosaurs. They lived in the shadows of giants, darting between ferns and rocky outcrops, feeding on insects, small vertebrates, and carrion. They were opportunists in a world of giants, and their time had not yet come. The vegetation of the Triassic world was starkly different from what we know today. There were no grasses, no flowering plants, no fruit-bearing trees. Instead, the land was covered in low cycads, towering horsetails, ginkgos, and fern forests that clustered near water sources. The interiors of Pangia were too dry for dense plant life, but along river valleys and coastal plains, greenery flourished. These oases were vital lifelines in a harsh, parched world, supporting entire food webs of herbivores and their predators. The climate was intense, shaped by the sheer size of Pangia and the lack of moderating oceans across its center. Seasons were long and unforgiving. Monsoons would bring heavy floods, turning dry riverbeds into raging torrents overnight. Then, for months on end, blistering heat would return, evaporating lakes and driving animals to the brink of exhaustion. Dust storms scoured the open plains. Lightning crackled across the sky, igniting wildfires that consumed vast stretches of land. It was a world in flux, always teetering between abundance and collapse. Earthquakes regularly rattled the landscape as tectonic pressures built beneath Pangia's crust. Massive volcanic eruptions were not uncommon. Towering basalt flows spilled across the land, reshaping entire ecosystems and poisoning the air with ash and gas. One such event, the Central Atlantic Magmatic Province, was already looming in the future, a pulse of volcanic activity that would ultimately coincide with a mass extinction event. But even before that catastrophe arrived, life had to contend with the relentless pressures of an unforgiving world. In this crucible of change, evolution worked with brutal precision. The weak perished and the adaptable survived. New traits began to emerge. Hollow bones made animals lighter and faster. Upright postures gave predators a better view of the landscape. Sharper teeth, more efficient lungs, and improved thermal regulation gave some species the edge they needed to outcompete their rivals. Natural selection moved quickly in the Triassic, and the foundation for the dinosaur age was already being laid. Despite the harshness of this world, it was not without beauty. Sunsets over Pangia bathed the rocky cliffs in gold and crimson. Herds of reptiles moved in synchrony across open plains, their scales glinting in the light. Deep canyons echoed with the calls of distant creatures, and ancient rivers carved pathways through primeval forests. In tidal flats, early marine reptiles like Nothosaurus slithered into the surf, chasing fish through the shallows. Even in the most extreme conditions, life found ways to thrive, to adapt, and to persist. Yet there was a sense of fragility to it all. The ecosystems of the Triassic were relatively new, recovering from the greatest extinction the planet had ever seen. The Permian-Triassic extinction had wiped out nearly 90% of all life, and the scars were still visible. Many ecological roles had not yet been filled. Niches lay empty, waiting for new players to evolve and take the stage. In this moment of emptiness, opportunity loomed large. And then came the tipping point. As the Triassic progressed, tectonic activity began to tear Pangia apart. The land cracked, creating rift valleys that would eventually become the modern Atlantic Ocean. These geologic shifts released enormous amounts of carbon dioxide into the atmosphere, warming the planet further and destabilizing the climate. Entire habitats began to vanish. Species that had ruled the Earth for tens of millions of years found themselves unable to cope. The great rauisuchians, once the apex predators, began to disappear. Amphibians retreated to shrinking wetlands. Even the once dominant cynodonts faded into extinction. In the void left behind, the early dinosaurs stepped forward. They were not yet dominant, but they were ready. Their small size, agility, and fast metabolism gave them an advantage in a collapsing world. They thrived in disturbed environments, scavenging where others starved, reproducing quickly, and expanding into every niche that opened. They moved into forests, plains, and coastlines. They spread across continents. And slowly, almost imperceptibly at first, they began to rise. A world before dinosaurs was a world of hardship and upheaval, but it was also a world of beginnings. It was the stage upon which nature rehearsed its greatest performance. The curtain had not yet risen, but the players were already in place. And as the sun set on the Triassic, casting long shadows across the bones of the past, a new dawn was approaching. A dawn filled with giants, with monsters, with marvels. The age of dinosaurs was about to begin. The moment that would reshape life on Earth did not begin with a roar, nor with the rise of a tyrant king. It began quietly, almost unnoticed, in the 2000 shadowy undergrowth of the Late Triassic. On a continent scorched by drought and rocked by volcanic tremors, something small and unassuming emerged. It had no armor. It had no massive teeth. It did not tower over the landscape or strike fear into the hearts of its rivals. Yet it carried within its bones the blueprint of an empire that would last for over 160 million years. This was the beginning. This was the birth of the first dinosaurs. In the fossil-rich badlands of modern-day Argentina, paleontologists uncovered a creature just over a meter long, delicate and agile. They named it Eoraptor, meaning dawn thief. It is one of the oldest known dinosaurs ever discovered, and it represents a key moment in evolutionary history. Eoraptor was lightly built with hollow bones, sharp claws, and a mouth filled with small serrated teeth. It walked upright on two legs, balanced by a long tail that acted as a counterweight. Its forelimbs, though short, were dexterous, and its eyes were positioned for binocular vision. Eoraptor was not a predator of great size, but it was a fast, opportunistic hunter, feeding on insects, lizards, and possibly even the eggs of other animals. But Eoraptor was not alone. In the same strata of time, other small theropods were evolving, each with subtle variations in design. Herrerasaurus was one of them. Larger and more heavily built than Eoraptor, Herrerasaurus reached lengths of up to 3 meters and had a more powerful skull, equipped with deep-set jaws capable of delivering crushing bites. Its limbs were muscular and built for speed, allowing it to chase down prey in bursts of terrifying acceleration. Though it was still primitive by later standards, Herrerasaurus represented a leap forward in the development of what would become the most iconic group of carnivores in Earth's history. These early dinosaurs shared a few key features that gave them an edge in the competitive world of the Triassic. First was their posture. Unlike the sprawling limbs of earlier reptiles, dinosaurs stood upright with their legs directly beneath their bodies. This design allowed for efficient movement and better endurance, particularly in the hot, dry climates of the time. Second was their respiratory system. While the lungs of modern reptiles are relatively simple, dinosaurs evolved a complex network of air sacs that extended into their bones, improving oxygen intake and allowing for higher activity levels. Third was their speed. Early dinosaurs were fast, agile, and highly responsive to environmental changes. They could move quickly between food sources, escape predators, and migrate to more favorable habitats as needed. But perhaps their greatest advantage was their ability to evolve rapidly. The Late Triassic was a period of instability. The breakup of Pangia was beginning, unleashing massive geologic and climatic upheavals. Ecosystems rose and fell within the span of a few million years. For animals that could not adapt, extinction was a death sentence. But for the early dinosaurs, each shift in climate, each new opening in the food web, was an opportunity. At first, dinosaurs were rare. They occupied the margins of ecosystems, avoiding direct competition with the dominant reptiles of the time. They were the fringe, the background players. But as the world changed, their numbers began to grow. Some became herbivores, adapting to feed on the ferns, cycads and ginkgos that covered the floodplains. Others specialized as insectivores or scavengers, finding niches that had gone untouched. And some, like Herrerasaurus, refined the art of predation. One of the reasons dinosaurs were able to diversify so effectively lies in their skeletons. They were modular, adaptable, and capable of wide variation. Their hips, in particular, came in two basic designs: Saurischian, or lizard-hipped, and Ornithischian, or bird-hipped. The Saurischians included the early theropods and sauropodomorphs, while the Ornithischians would later give rise to armored dinosaurs, horned dinosaurs, and duck-billed herbivores. This division allowed for an incredible range of body plans and feeding strategies. From the same basic framework, evolution could create both lightning-fast hunters and hulking, long-necked grazers. By the middle of the Late Triassic, dinosaur species had begun to spread across what is now South America, North America, Africa, and India. Because Pangia was still mostly intact, animals could migrate across vast distances, and the fossil record shows striking similarities in dinosaur species found on different continents. This global distribution helped reinforce their dominance. No matter where they went, dinosaurs adapted. They learned to survive in humid forests, dry deserts, and coastal lowlands. Still, their reign was not guaranteed. The rauisuchians, those powerful crocodile-like predators, still ruled many regions. Even some large amphibians, like the metoposaurs, posed serious threats to young dinosaurs. And yet, cracks were beginning to show. Many of the dominant Triassic reptiles had highly specialized lifestyles. They were large, slow to reproduce, and vulnerable to environmental changes. The dinosaurs, by contrast, reproduced quickly, had flexible diets, and were physically capable of surviving in harsher conditions. Natural selection began to tip in their favor. A turning point came with the End Triassic Extinction event, a global catastrophe triggered by intense volcanic activity as Pangia continued to break apart. Massive volcanic eruptions released vast amounts of carbon dioxide and sulfur dioxide into the atmosphere. The climate destabilized. Ocean acidification wiped out marine species. Wildfires raged across the continents. Food chains collapsed. In the chaos, many of the dominant reptiles were wiped out. The rauisuchians vanished. The metoposaurs disappeared. Even the once thriving cynodonts, which had held on since the Permian, finally succumbed. But the dinosaurs endured, not because they were the strongest, but because they were the most adaptable. When the skies darkened and the temperatures plummeted, the small, quick-footed dinosaurs could move to new refuges. When food became scarce, they switched diets. When competitors vanished, they expanded into empty territories. They did not just survive the extinction, they thrived in its aftermath. And in doing so, they secured their place at the top of the world's food chains. It was in this crucible of disaster and recovery that the foundations of the dinosaur empire were laid. Over the next few million years, their numbers would explode. Species would radiate into every corner of the planet. The delicate limbs of Eoraptor would evolve into the powerful legs of Tyrannosaurus rex. The sharp teeth of Herrerasaurus would echo in the sickle-shaped claws of Velociraptor. The small-bodied insectivores would give rise to the armored stegosaurs and the enormous titanosaurs. From humble beginnings, an empire was born. The birth of the first dinosaurs is a story not just of anatomy and survival, but of timing. They did not appear in a world of peace and stability. They appeared at a time of chaos when ecosystems were broken and life was clawing its way back from the edge of extinction. They succeeded not because they were destined to, but because they had the right tools at the right time. They were fast, flexible, and efficient, and above all, they were survivors. Today, when we walk through a forest and hear the call of a bird, we are hearing the echoes of that moment. For the dinosaurs never truly vanished. They changed, they adapted, and in the end, they outlasted even the age that once belonged to them. In the heart of Pangia's arid interior, where the wind howled across sun-baked rock and the cracked earth stretched toward the horizon, life had found a new way to endure. The deserts of the Late Triassic were vast and unforgiving. Rains came only in short, violent bursts, and rivers dried into dust within weeks. Vegetation clung to riverbanks and deep canyons, while the open plains remained barren and scorching. Yet in this seemingly lifeless land, one of the first great dinosaur hunters emerged. Swift, slender, and deadly. Its name was Coelophysis. Coelophysis was a predator perfectly adapted for survival in this brutal landscape. It stood nearly a meter tall at the hips and stretched over 3 meters in length, but its lightweight, hollow-boned frame kept it under 20 kilograms. It was built for speed and endurance. Its long legs could carry it across open plains in pursuit of prey or away from danger in an instant. Its arms, though small, were equipped with sharp claws, and its mouth housed rows of needle-like teeth designed to pierce and grip flesh. It did not overpower its prey. It outran it, outmaneuvered it, outlasted it. This dinosaur thrived in the American Southwest, where its fossilized remains now sleep beneath layers of red rock in what we call Ghost Ranch, New Mexico. This ancient desert was once a land of seasonal floods and droughts, where Coelophysis hunted along ephemeral rivers and dried lake beds. Its world was unpredictable, shaped by shifting weather patterns and ecological instability. But Coelophysis was a master of unpredictability. It did not need lush forests or abundant prey. It only needed a chance. What made Coelophysis truly remarkable was not just its anatomy, but its behavior. The fossil beds of Ghost Ranch contain hundreds of Coelophysis skeletons buried together in what appears to have been a sudden catastrophe. Perhaps a flash flood or toxic algal bloom that poisoned the water. This mass death site tells us something critical. These dinosaurs lived in groups. Whether they moved in coordinated packs or loosely associated herds remains uncertain, but the evidence suggests they were social. And in the desert, social behavior brought an edge. In numbers, they could protect their young. They could share kills. They could overwhelm prey that would be too risky to tackle alone. Their coordination turned the harshness of the desert into an opportunity. Their diet was as flexible as their lifestyle. Coelophysis hunted small vertebrates, lizards, amphibians, and smaller reptiles, but it also likely scavenged when needed. Fast, needed, efficient, and opportunistic. It filled a role once held by the now declining rauisuchians. It was the new model of predator. Lighter, faster, smarter. There is even evidence, though debated, that Coelophysis may have resorted to cannibalism in extreme conditions. Some fossils show juvenile bones inside the body cavities of adults, suggesting that during times of starvation, these hunters turned on their own. If true, it speaks to the desperation that sometimes gripped the desert and to the savage instincts that survival demanded. The world of Coelophysis was one of extremes. The days scorched the land and the nights froze it. Rainfall, when it came, arrived in torrents, washing away soil and life alike. Plant life was sparse. Ferns and small cycads clung to shaded gullies. Waterholes became battlegrounds. Herbivores like aetosaurs, armored with bony plates, moved cautiously along the rivers. They had to be alert. Coelophysis was always watching. But Coelophysis itself was not invulnerable. It had enemies. Larger predators like rauisuchians still roamed in some regions, and even within their own species, the constant struggle for dominance, territory, and food could turn deadly. Juvenile Coelophysis likely made up the bottom of the food chain, vulnerable not just to predators, but also to the harsh environment. Few made it to adulthood. Yet, despite these threats, Coelophysis thrived. Its success wasn't just about physical traits, it was about timing. It emerged at a moment when the old rulers of the land were beginning to falter. The massive amphibians were retreating to shrinking wetlands. The top reptilian predators were becoming too large and specialized to adapt quickly. Coelophysis, lean and versatile, slipped into the vacant ecological space with precision. Its legacy would be immense. Coelophysis was part of the early wave of theropods, the lineage that would eventually give rise to some of the most iconic carnivores in history. From its slender frame would come the brutish might of Allosaurus, the cunning intelligence of Velociraptor, and the overwhelming power of Tyrannosaurus. It was a prototype, a glimpse into the future of predation. But in the late Triassic, it was already a master of its domain. It ruled the desert with speed, awareness, and cooperation. It showed that size was not everything, that strategy, agility, and adaptability could outmatch brute force. In the Age of Giants, Coelophysis was the whisper of a new era, the era of the agile hunter. Its fossilized bones, locked in ancient stone, speak not just of death, but of dominance, of a creature that learned to run with the wind, to strike with precision, and to live in one of the most difficult environments Earth had to offer. And as we trace its slender skull, its long legs, its delicate ribs, we begin to understand that Coelophysis was not just another dinosaur. It was a signal that the world had changed, and a new kind of predator had arrived. The rise of giants did not begin with towering necks reaching into the treetops, or with herds thundering across open plains. It began in silence, with creatures that moved slowly, fed constantly, and grew steadily across the unforgiving landscapes of the late Triassic. These were the ancestors of giants, the first massive herbivores to walk the earth, the sauropodomorphs. In the scattered forests and floodplains of Pangia, where cycads clustered near rivers and ferns blanketed the lowlands, a new breed of plant-eater began to appear. One of the earliest and most successful was Plateosaurus. This creature stood at the crossroads of evolution, not yet a true sauropod, but already showing hints of the enormous creatures to come. It measured up to 10 meters in length and could weigh over 4 tons. It walked primarily on 2 legs, but its strong forelimbs allowed it to drop to all 4s when needed. Its neck was long and flexible, its skull small and narrow, and its mouth filled with leaf-shaped teeth, perfect for stripping vegetation. Plateosaurus and its relatives were pioneers. they explored a new strategy in the game of survival. By growing larger, they became more difficult for predators to kill. A juvenile might fall victim to a Colophyses or a rauisuchian, but an adult was nearly untouchable. Their sheer bulk served as both defense and deterrent. But size alone was not enough. These early giants had to eat, constantly. They lived in a world where flowering plants had not yet evolved, where grasses did not exist. Their diet consisted of tough, fibrous plants, horsetails, ferns, cycads, and conifers. Digestion was slow and inefficient, so they likely relied on massive gut volume and bacterial fermentation to extract nutrients. They may have swallowed stones to help grind plant material inside their bellies, a behavior seen in their later descendants. To support their growing bodies, sauropodomorphs evolved robust bones and thick muscles. Their legs were like columns, designed to bear immense weight. Their feet spread wide, balancing their mass across the soft, muddy ground of river valleys and lake beds. As they walked, they left deep impressions in the earth, footprints that would fossilize into the ancient record of movement, migration, and growth. The environment was both a blessing and a challenge. Pangia's vastness created extreme climates. In the interiors, droughts were common and vegetation sparse. Along the coasts and river systems, monsoons turned the ground to marsh and flood. Early giants had to navigate this unpredictability. They followed water, they followed food. They moved in small groups, possibly herds, seeking safety in numbers and stability in motion. But life at such a scale came with risk. They grew slowly, and young individuals were vulnerable for years. Predators remained a constant threat. Rauisuchians still prowled the land in the early stages of sauropodomorph expansion, and even the smaller theropods like Herrerasaurus or Coelophysis could pick off the weak or sick. Vigilance became critical. Survival was a matter of growing quickly and staying close to the group. Their evolution was not isolated. Across Pangia, similar forms began to appear. Massospondylus in what is now South Africa, Rauisuchians in Argentina, and Ankylosaurus in North America all displayed the same trends: increasing body size, longer necks, and a commitment to herbivory. Evolution was repeating the same idea in different regions: get big, eat plants, live longer. This shift in body plan also altered ecosystems. The rise of large herbivores meant that plants had to adapt. Some developed tougher leaves. Others spread quickly by spores or grew in dense groves, outpacing the mouths that grazed them. Predators, too, had to respond. Small hunters were no longer enough. Only the largest, most powerful carnivores could threaten a healthy adult sauropodomorph. This drove an arms race, a biological escalation that would eventually give rise to the enormous predators of the Jurassic. But in the Triassic, these were still early days. The giants were only beginning to rise. They walked in a world where the rules were changing, where power came not from sharp claws or deadly speed, but from persistence, scale, and strength. And their rise marked a fundamental shift in how ecosystems operated. They created pressure. They shaped landscapes. They ate trees and trampled forests. They moved across continents and spread their genes to every corner of the ancient world. The sauropodomorphs became the backbone of late Triassic ecosystems. Where they traveled, others followed: predators, scavengers, smaller herbivores, and opportunists. Their migrations mapped the flow of resources. Their droppings fertilized the soil. Their deaths fed the carnivores. They were walking ecosystems unto themselves, and in time, they would grow larger still. Their descendants would stretch beyond imagination, Diplodocus, Apatosaurus, Argentinosaurus, creatures whose necks reached above trees and whose steps shook the ground. But all of that began here, in the late Triassic, with creatures like Plateosaurus quietly grazing under the shadow of conifer trees, slowly becoming giants. The story of their rise is not just one of size, it is one of transformation, of how a lineage of small, nimble reptiles evolved into Earth's largest land animals. It is a story of adaptation, patience, and deep time. Of how the pursuit of plants and safety led to bodies the size of buildings. Of how a world once ruled by fear gave birth to life that conquered through endurance. They did not hunt, they did not roar, but they left their mark on every inch of the earth. The giants had begun their rise, and nothing would ever be the same. The ground trembles. Distant thunder rolls through the earth, not from the sky, but from deep beneath the crust. The air carries the bitter tang of sulfur. Animals pause mid-step. Forests fall still. And then it begins. A crack splits the land open. Fire pours from the wound. Black smoke rises into the sky. This is not the wrath of a storm. It is the fury of the planet itself. In the Triassic world, survival was not only a matter of escaping predators or finding food. It meant living alongside a planet that never rested. A world of constant upheaval. And nothing symbolized that more than the volcano. In the late Triassic, Pangia was a landmass under stress. The immense pressures beneath its crust had begun to fracture it apart. Over millions of years, rift valleys opened. Magma surged upward. Entire regions became fields of fire. Volcanoes lined the edges of continents, their eruptions reshaping the landscape again and again. One of the largest of these events, the Central Atlantic Magmatic Province, would eventually unleash a cataclysm that helped end the Triassic period altogether. But even before that final eruption, volcanoes played a constant role in the lives of the animals who called this world home. For early dinosaurs, volcanic activity was a fact of life. Some regions, like what is now Argentina, were rich in fossil beds layered between ancient lava flows and ash deposits here. Creatures like Eoraptor, Herrerasaurus, and Plateosaurus once roamed through forests that grew on freshly cooled basalt. The soil, though born of destruction, was often rich in minerals. After an eruption, new growth would follow. Ferns, horsetails, and cycads flourished in volcanic soil, drawing herbivores back to the land. Predators, in turn, followed them. But the danger never disappeared. Ash could fall without warning, burying plants and suffocating lungs. Animals caught too close to lava flows were entombed in stone lakes and rivers, poisoned by volcanic gases, became deadly traps. And sometimes the eruptions themselves were sudden and massive, pyroclastic surges of heat, gas, and ash rushing down slopes faster than any creature could run. Survival in this world meant more than strength. It meant awareness. It meant movement. It meant knowing when to flee. Those who lived near volcanic regions had to adapt in subtle ways. Small size offered advantages: faster escape, easier shelter, and lower food needs during lean times. Creatures like Calophysis could dart into crevices or flee across open land at high speed. Burrowers may have avoided the worst effects of ashfall. Others may have followed migration patterns that avoided active zones, returning only when the land had cooled and regrown. For larger animals like Plateosaurus, survival required endurance. They had to travel long distances to avoid danger zones. Herds likely followed ancient paths, retreating from erupting centers and returning months or years later. Their bones show growth rings, like trees, revealing times of abundance and times of stress. In years following eruptions, their growth slowed. Starvation left its mark in their skeletons. The volcano left its mark on their lives. But there were benefits too. As destructive as volcanoes were, they also reset ecosystems. They wiped out dominant competitors, opened new habitats, and allowed adaptable species to flourish. This cycle of destruction and renewal became a driving force in evolution. It rewarded resilience, innovation, and flexibility. It punished specialization and stagnation. The dinosaurs that survived were those that could navigate this cycle again and again. The skies, too, were changed by volcanoes. Massive eruptions could send ash and sulfur into the upper atmosphere, dimming sunlight and lowering global temperatures. These volcanic winters could last for years, disrupting plant growth and collapsing food chains. Animals starved, migrations failed, breeding cycles broke down. Yet again, some survived. Small omnivores, insectivores, and scavengers proved the most resilient. They could shift diets. They could shelter in caves or burrows. They could wait. Fossil beds show patterns of sudden disappearance, followed by bursts of new species appearing in the record. These evolutionary radiations often followed major eruptions. The land would empty and then refill. Survivors expanded into abandoned niches. Predators returned in new forms. Herbivores diversified. And always in the background, the volcano rumbled on. In some places, lava flows formed natural barriers, creating isolated pockets of life. Species trapped in these zones evolved in unique directions. This isolation sparked diversity. Small valleys cut off by lava became islands of evolution, where local populations developed traits found nowhere else. This was how nature built novelty, with walls of fire and time. The impact of the volcanic world was not limited to animals. It shaped the very surface of the Earth. Entire mountain ranges rose from ancient magma chambers. Flood basalt stretched for hundreds of kilometers. The rocks themselves carried records of ancient eruptions, layered in basalt, ash, and sediment. And within those layers lay bones, frozen moments of life, death, and adaptation. The Central Atlantic magmatic province would eventually become one of the largest volcanic events in Earth's history. It covered millions of square kilometers across what is now eastern North America, northwestern Africa, and parts of Europe. It released vast quantities of greenhouse gases, warming the planet and disrupting ocean currents. The resulting extinction event wiped out over half of all marine species and many land animals. But dinosaurs once again survived. They did so because they were built for chaos. They did not depend on a single habitat. They moved, they adapted, they diversified. Their bodies were efficient. Their lungs could handle low oxygen levels. Their eggs, buried in soil, were protected from ash and heat. Their young grew quickly, recovering populations faster than slower reproducing rivals. They were the right creatures for a dangerous world, and so they thrived. In the wake of each eruption, each collapse, they returned. They grazed on new plants, they hunted in new forests, they expanded across continents reshaped by fire. Their resilience became their legacy. To survive in the volcanic world of the Triassic was to live in constant uncertainty. It was to face disaster not as an anomaly, but as a way of life. Those who adapted endured. Those who resisted vanished. And in this crucible of fire and ash, the dinosaurs were forged. In the ancient wilds of Pangia, survival was never simple. Every mouth that fed, every footprint that touched the soil, was a signal to another creature. It said, "I am here, I am alive, and I may be your rival." In this world, competition was constant for food, for water, for territory, for air to breathe and space to grow. And in the relentless pressure of competition, evolution sharpened its tools. Those who adapted quickly spread. Those who failed to adapt disappeared. This was the rule of life in the Late Triassic, a time where extinction was not a distant threat, but a regular fact of existence. As early dinosaurs like Coelophysis, Herrerasaurus, and Plateosaurus expanded across Pangia, they did not do so on an empty stage. They entered ecosystems already teeming with strange and powerful creatures. The great rauisuchians, towering crocodile-like reptiles, had long held dominion as apex predators with their pillar-like limbs and deep skulls. They were perfectly built for ambush, crushing prey in a single bite. These reptiles, some over 6 meters long, had no equal for decades. Their armor-plated skin made them nearly invincible to attack. For early dinosaurs, avoiding them was a matter of life or death. But rauisuchians had weaknesses. They were large, heavy, and specialized. Their growth was slow, their reproduction even slower. When the climate shifted or prey became scarce, they struggled to keep up. And behind them, in their shadow, smaller, faster predators like Herrerasaurus were watching. Not as strong, but more flexible. Not as large, but more numerous. The competition was not direct at first. Dinosaurs scavenged the edges, hunted smaller prey, moved quickly while the giants lumbered. But slowly, as droughts came and forests fell, as prey populations changed and volcanic eruptions shattered the land, the balance began to shift. Even among herbivores, the competition was fierce. Early sauropodomorphs like Plateosaurus fed side by side with older groups such as the cynodonts. These tusked, beaked plant eaters were remnants of a previous age, survivors of the Permian extinction. They had endured catastrophe once before, but now they were fading. Slow, low-slung, and dependent on specific plant types, they found themselves outmatched. Sauropodomorphs could travel farther, eat higher, grow larger, and they did. One generation after another, their numbers swelled, and the dicynodonts withdrew into smaller and smaller territories. Insects played a quiet role in this struggle. They pollinated the limited plant life, broke down decaying matter, and became food for smaller predators. But as plant diversity slowly began to shift and the climate grew more seasonal, insect populations changed too. Those that could adapt survived. Those that could not vanished. Everything was connected. A decline in ferns could mean a decline in insect populations. A decline in insects could affect the diets of small reptiles and juvenile dinosaurs. The fall of one species often led to the fall of many. Competition was not only direct, it was ecological, invisible. A chain of consequences set in motion by climate, by geology, by biology. The skies held their own conflicts. Early pterosaurs had taken to the air, gliding on membranous wings, hunting fish and insects, nesting on cliffs and crags. They had few rivals in the air, but their survival depended on what happened below. Without a healthy land ecosystem, there were no insects to feed on, no fish in the rivers, no quiet places to nest. Even the masters of flight could fall if the land beneath them broke. Predation itself became more sophisticated. Coelophysis, small and swift, likely hunted in coordinated groups. Not complex packs like wolves, but enough cooperation to take down larger prey or overwhelm defensive species. This was a new kind of competition, one not just of size or strength, but of intelligence and social behavior. Predators were learning to adapt together, to move as units, to hunt not just what was easy, but what was efficient. And then, just as dinosaurs were beginning to secure their hold, the world struck back. The end Triassic extinction event arrived not as a single blow, but as a prolonged catastrophe. Extinction, though devastating, is also an engine. It clears the path for the new. And in the aftermath of the Triassic collapse, the dinosaurs no longer had to compete with the old giants. The field was open. The predators were gone. The rivals were gone. And into that vacuum, they exploded. New forms, new sizes, new strategies. Evolution accelerated. By the time the Jurassic period dawned, the dinosaurs were no longer just survivors. They were rulers. The competition had ended in fire, and the victors had emerged from the ashes. They would dominate the next 160 million years. They would grow larger, smarter, faster. They would conquer the skies, the seas, and every continent. And it all began here, in the crucible of extinction. This was the moment when the old world ended and the age of dinosaurs truly began, not with triumph, but with survival. The land cracked, the skies shifted, the winds turned. Nothing on Earth was still, not even the climate. During the Late Triassic, the planet was a world in flux. Massive forces deep within the Earth pushed continents apart. Seas rose and fell. Monsoons thundered across vast plains only to vanish into years of silence. Drought, flood, fire, and frost came and went like clockwork without rhythm. Life had no choice but to bend or break. Pangia, the supercontinent that stretched across most of the globe, played a crucial role in shaping the climate of the Triassic. With nearly all landmass fused into one, the interior was dry, hot, and hostile. Moisture from surrounding oceans rarely penetrated far inland. As a result, central Pangia became a realm of deserts and semi-arid landscapes. Only near the coasts and large inland lakes did dense vegetation and more stable ecosystems form. It was a world divided, not by borders, but by air and heat. Temperatures in many parts of the planet soared beyond what is common today. The absence of polar ice allowed greenhouse gases to accumulate, amplifying the heat. Yet, despite the warmth, the world was not stable. Volcanic activity from deep fissures in the Earth released enormous amounts of gases into the atmosphere. Each eruption sent shockwaves not just through the ground, but through the climate system. Sulfur dioxide created acid rain. Carbon dioxide drove heat. Ash clouds darkened the skies, reflecting sunlight and temporarily cooling the surface. The result was a planet caught in wild climatic swings. Years of scorching heat could suddenly give way to brief volcanic winters. Periods of abundant rain could shift without warning into seasons of drought. These changes did not follow familiar cycles. They were erratic, violent, and unforgiving. Life on Earth had to adapt or perish. The plants of the Triassic were tough and unyielding. Ferns and horsetails, with their ancient reproductive cycles, spread quickly after fire or flood. Cycads and conifers developed waxy coatings to withstand dry conditions and conserve moisture. But even the hardiest plants struggled under the pressures of climate change. Entire forests could vanish in a matter of years, their collapse cascading through the food web. Herbivores followed the plants. When the greenery disappeared, so did the herds. Early sauropodomorphs, dependent on ferns and cycads, had to move constantly in search of food. Their migrations stretched for hundreds of kilometers, chasing rain and regrowth. The young were especially vulnerable. A single failed season could mean starvation for entire generations. Predators, too, felt the pressure. Creatures like Coelophysis relied on small prey, insects, lizards, amphibians. When droughts dried up rivers and killed off insect populations, the hunters were left to scavenge or turn on each other. The fossil record hints at periods of intense stress, where even cannibalism may have emerged in desperation. The skies mirrored the chaos below. Storms tore across the land, lightning igniting wildfires that consumed whole valleys. Ash from distant eruptions drifted for hundreds of kilometers, settling on forests and rivers alike. Clouds of gas sometimes hugged the ground, choking lowlands and poisoning water sources. These were not just weather patterns. They were weapons of extinction. In the oceans, things were no better. Increased carbon dioxide from volcanic activity acidified the seas, disrupting the fragile balance of marine ecosystems. Coral reefs struggled to grow. Plankton populations fluctuated wildly. And, as oxygen levels dropped in deeper waters, vast dead zones spread. Marine reptiles that had once dominated coastal regions had to retreat or adapt to shallower, more oxygen-rich waters. The chain reaction continued, from plankton to predator, reshaping the very chemistry of life. Despite the hardship, some life forms thrived in the chaos. The early dinosaurs, small and lightweight, flexible in diet and behavior, found ways to endure. Their bodies were designed for efficiency. Their lungs pulled in oxygen more effectively. Their eggs could be buried and shielded from harsh conditions. They could move, migrate, repopulate. They didn't need perfect conditions. They only needed opportunity. Their adaptability was not accidental. It was forged in fire and drought and storm. Every shift in temperature, every failed season, every vanished species became a test. And the dinosaurs passed those tests again and again. But for others, the changing climate spelled doom. The great rauisuchians, apex predators of the early Triassic, relied on stable ecosystems and abundant prey. When those systems collapsed, so did their dominance. The cynodonts, relics of an older world, could not compete with the rising tide of new herbivores. Amphibians tied to water sources and delicate habitats found fewer and fewer places to call home. Their decline was slow at first, then sudden. Even the soil itself changed. Ash and lava transformed fertile land into barren rock. Rivers altered course. Lakes dried up or became acidic pits. Over time, entire biomes shifted. Regions that had once been forests became deserts. Coastlines receded. Ecosystems fragmented. Species were pushed into isolated pockets, some adapting in isolation, others fading into extinction. The climate had become the ultimate predator. It did not hunt. It did not bite. But it killed all the same. Slowly, invisibly, relentlessly. And yet, in the midst of all this chaos, evolution flourished. The pressure of survival accelerated change. New species emerged. New strategies evolved. Life didn't give up. It innovated. The harshness of the world forced nature to experiment, and the experiments that worked gave rise to the creatures that would define the Mesozoic era. This is the paradox of deep time. That destruction creates space. That upheaval creates room for growth. And that those who survive the worst often become the strongest. As the Triassic came to a close, the planet stood on the edge of a new chapter. The age of dinosaurs, shaped by heat and storm, was about to begin its reign. They had survived the changing climate. Now they would shape the climate of the future. As the Triassic period drew to its end, the world stood on the edge of transformation. For tens of millions of years, Earth had been a place of chaos and recovery, recovering from the greatest extinction in history, reshaping its continents, and testing life with every tool of destruction it had. The creatures that walked its surface had changed with each passing era, rising and falling like the layers of sediment that would later entomb them. But now, something was different. Something permanent. The stage was finally clearing, and the spotlight was shifting. This was the moment the age of dinosaurs truly began. It did not happen overnight. It was not the sudden roar of tyrannosaurs or the crash of sauropod herds. It began in silence, in the wake of an extinction. They had already existed for millions of years, scattered across Pangia in modest numbers, small and agile creatures competing with older reptilian clades. Every open niche, every abandoned territory, every vacated role in the food web became an invitation. And the dinosaurs accepted. Theropods, the two-legged carnivores, quickly filled the role of top predator. No longer shadowed by the rauisuchians, they began to grow larger, more powerful, more specialized. Their bodies, once slim and modest, evolved into deadly hunting machines. Longer limbs, sharper claws, stronger jaws, all shaped by the new freedom to dominate. Soon, the first true apex theropods emerged, paving the way for the great hunters of the Jurassic and beyond. Sauropodomorphs, too, took advantage of the moment. With their competition gone, they grew in size and number. Their necks stretched longer to reach the highest foliage. Their bodies expanded into titanic forms that reshaped the land beneath their feet. They moved in herds, tracked the rains, and transformed entire ecosystems with their grazing. Where once they had been one group among many, now they became the foundation of every terrestrial ecosystem on the planet. Ornithischians, the bird-hipped dinosaurs, began their own silent revolution. Though they remained smaller and less numerous at first, they diversified rapidly. From them would later come the horned ceratopsians, the armored ankylosaurs, and the duck-billed hadrosaurs. Each one a future masterpiece of adaptation, and all of them descendants of the quiet survivors who endured the extinction. What set dinosaurs apart was not just biology, but opportunity. They had time. With their rivals extinct and ecosystems resetting, the dinosaurs had the space to evolve, to experiment, to diversify. They filled roles large and small. From apex predators to ground-level foragers, from towering browsers to nimble insect eaters. They were no longer fringe creatures. They were the architects of a new world, and the world itself was changing with them. As Pangia continued to rift apart, new oceans formed. Climates became more regional. Rainfall patterns shifted. The air grew more oxygen-rich. Ecosystems became more complex, and dinosaurs followed, adapting to each new biome, colonizing every landmass. Fossil evidence shows their footprints across every continent, from Arctic forests to equatorial swamps. Their success was not local, it was global. With their rise came a new rhythm of life. Migration patterns expanded. Predator-prey dynamics became more intricate. Ecosystems stabilized around dinosaur activity. And as they spread, they brought with them other survivors. The success of dinosaurs shaped the evolution of everything around them. This was no longer the scattered emergence of isolated species. It was a full-scale takeover. The dinosaurs had become the dominant life forms on Earth. They ruled not because they were the most ferocious, but because they were the most adaptable. Their story had begun in the shadow of extinction. Now they cast shadows of their own. From this point forward, Earth entered the Mesozoic era, an age that would last more than 160 million years, defined by the rise, rule, and eventual fall of the dinosaurs. Their empire would span epochs, outlasting ice, fire, and flood. They would grow to unimaginable sizes, evolve into strange and beautiful forms, and dominate skies, land, and sea. But none of that could have happened without this moment, the quiet turning of the tide at the end of the Triassic. This was the threshold, the closing of an ancient chapter, the beginning of something new. A world without rauisuchians, without cynodonts, without the amphibian titans of the past. A world where dinosaurs would write the next verses of Earth's story in the tracks they left behind. The age of dinosaurs had begun, and the world would never be the same.